Hey guys, in a previous video I shared with you my flood fill algorithm. It wasn't very efficient, but it was fun to watch. And I've been actually looking for a replacement flood fill algorithm that does a much better job, and I think I found one, and I'm going to share that with you as well. So I found this page, and you can see the URL. I'll try and put it in the description in the video so you could click on it and go to it directly. But in case I forget, you should be able to read it off the screen here. Um, and this person here implements a scanline fill, which looks to be much better than my algorithm. So I wanted to try it. And the only thing is that this was in C sharp. I wasn't quite sure if I could do a direct translation. You might have use some specific features of C sharp that I might not be able to convert, but I've managed to convert it and it looks like it's working fine. I'll do some further testing, but so far it looks fine. There's also a smaller flood fill algorithm that uses recursion, and I've copied that as well and converted that over. And that's not very good, but we'll test all of them and see how they work. So I'm going to jump to my free Pascal um, editor here, compiler, and let me just show you which version I'm using. So I'm using the Go32 version 2, and this is the latest version at this time. And I've renamed my original flood fill algorithm to Nick Flood here. And if we run it, let's go through the whole process again. We can see that, filling a small square does it pretty good. But let's go outside the small square and see how it works with a much bigger area to cover. So, it's working much faster because I'm using the free Pascal compiler. But it didn't fill everything, and that's because the settings I currently have. Let me go here. So I have this setting here with the amount of uh, size I can use in these arrays, and I have it limited to 2000, and that's because I was using Turbo Pascal, and that has a much greater limit on how much memory you can access. But with this, I could increase it, I believe, all the way up to 10,000. So let's do that and see how it works now. So now it works properly. It fills the whole screen. So let's see how the recursion version of the algorithm works from this website. I'm going to comment in my algorithm. And I didn't comment properly. Okay. So that worked as well. Let's go outside the box. And there we go. It crashed the compiler, the runtime. So that's not very good. So let's comment that, and this time we're going to be using this algorithm from this website. Let me switch to it. So we're going to be using this algorithm. Let me flip back and show you my converted version. So it looks very similar. Let's find it. Here it is. So I'll put all this on my GitHub, and you could take a closer look. But let's see if we can do a side by side. Yeah, so let's do this. Okay, so I'm looking at the wrong one. Okay, and this should look closer to what we have here. So I was able to convert it pretty much line by line with an equivalent Pascal version. The only thing I had to implement was my own little pop and push stack object, and it's very simple, and but it seems to do the job, so it works. So let's just try running this now and see how it performs. Okay, I think I crashed the DOS box. It might have been from the previous recursive version of the flood fill. So let's try this again. And there we go. So that worked just fine, filling the small square. And let's go out of the small square and see how well it works with the. Okay, really good. So really fast. Now I'm going to exit this and run Turbo Pascal. Okay, so we're running the same. And in Turbo Pascal, if you notice how it's working much slower, so that's the advantage of using a free Pascal. Same code, but just a whole lot faster because it's a better compiler for this kind of work. So if you're ever wondering if the free Pascal graph library is any good, it to me it looks like it actually performs much faster than the Turbo Pascal version. So that's it. I'll end this here. I'll put the code on my GitHub, and maybe next time I'll try a different algorithm. There's one here on a code project that I've been looking at. It's also in C sharp, but I'm not quite sure I can convert this over because it has a lot of things I'm not familiar with. But who knows? All right, and that's where I will end this.